For centuries, humanity has looked at the stars with wonder, but now we stand on the edge of becoming an interplanetary species. In this video, we'll explore how we could colonize space, the challenges we'll face, and what the future holds for humanity among the stars. Natural disasters, resource depletion, and overpopulation are some of the pressing issues we face on Earth. By colonizing space, we can ensure the survival and expansion of the human race. Imagine futuristic space cities, thriving communities beyond our home planet. The potential is, well, limitless. The Moon, with its proximity to Earth, is a prime candidate for our first off-world colony. Mars, with its similarities to Earth, offers a more long-term habitat. Space stations, like the O'Neill cylinders, could serve as self-sustaining habitats in orbit. And beyond Mars, who knows what possibilities await us in the vast expanse of space. Space colonization comes with a host of challenges that we must overcome. As humanity looks to the stars, dreaming of establishing colonies on the Moon, Mars, and beyond, we are faced with numerous obstacles that test our ingenuity and resilience. These challenges are not just technical, but also biological, psychological, and logistical. Each one presents a unique set of problems that require innovative solutions. The dream of living among the stars is tantalizing, but the path to making it a reality is fraught with difficulties that we must address head-on. First, there's the issue of radiation. Space is filled with high-energy particles that can be harmful to humans. Unlike Earth, which is protected by its magnetic field and atmosphere, space offers no such shield. These particles, often originating from the sun or distant cosmic events, can penetrate living tissue, increasing the risk of cancer and other health issues. To protect astronauts, we need advanced shielding technologies. Current spacecraft use materials like aluminum and polyethylene, but future missions may require more sophisticated solutions, such as magnetic fields or water-based shielding, to ensure the safety of those on board. Space is filled with high-energy particles that can be harmful to humans. These particles, known as cosmic rays, are a significant concern for long-duration missions. Researchers are exploring various methods to mitigate this risk, including the use of pharmaceuticals that can repair radiation damage at the cellular level. Additionally, the design of spacecraft and habitats must incorporate materials and structures that can effectively block or deflect these particles. The challenge is to create a balance between protection and practicality, ensuring that the solutions are both effective and feasible for space travel. Then there's the challenge of microgravity. In the microgravity environment of space, the human body undergoes significant changes. Muscles weaken, bones lose density, and fluids shift towards the head, causing a range of health issues. To counteract these effects, astronauts must engage in regular exercise using specialized equipment designed for use in space. However, exercise alone is not enough. Researchers are investigating other countermeasures, such as pharmaceuticals and artificial gravity, to help maintain the health and well-being of space travelers. Understanding and mitigating the effects of microgravity is crucial for the success of long-term missions. Spending extended periods in low gravity can lead to muscle atrophy and bone loss. These changes can have serious implications for astronauts, affecting their ability to perform tasks and increasing the risk of injury. To address this, space agencies are developing new exercise protocols and equipment, such as resistance bands and advanced treadmills, to help maintain muscle and bone health. Additionally, research into nutritional supplements and other interventions is ongoing, with the goal of finding effective ways to support the physical health of astronauts during long-duration missions. Extreme environments are another concern. Space is a vacuum with extreme temperatures, making it a hostile place for human life. Temperatures can swing from scorching heat to freezing cold in a matter of minutes, depending on exposure to the sun. Spacecraft and habitats must be designed to withstand these harsh conditions, using advanced materials and insulation to maintain a stable internal environment. Engineers are also exploring the use of active thermal control systems, which can regulate temperature by circulating fluids or using radiators to dissipate heat. Ensuring the safety and comfort of astronauts in such extreme environments is a critical aspect of space colonization. Space is a vacuum with extreme temperatures, making it a hostile place for human life. The lack of atmosphere means there is no medium to conduct heat. leading to rapid temperature changes. This poses a significant challenge for the design of spacecraft and habitats, which must be able to protect occupants from these extremes. Advanced materials such as multi-layer insulation and heat-resistant coatings are essential for maintaining a stable internal environment. Additionally, the development of efficient thermal control systems is crucial for managing heat generated by electronic equipment and other sources within the spacecraft. Psychological challenges also come into play. The isolation and confinement of space travel can take a toll on mental health. Astronauts are separated from their families and friends for extended periods, living in small confined spaces with limited privacy. This can lead to feelings of loneliness, anxiety, and depression. To address these issues, space agencies are implementing measures to support the mental well-being of astronauts. This includes providing opportunities for regular communication with loved ones, offering psychological support services, and designing living spaces that promote a sense of community and well-being. Understanding and addressing the psychological challenges of space travel is essential for the success of long-term missions. The isolation and confinement of space travel can take a toll on mental health. To mitigate these effects, space agencies are exploring various strategies such as virtual reality environments that can simulate familiar settings and provide a sense of escape. Additionally, the development of social support networks among crew members is crucial, fostering a sense of camaraderie and teamwork. Regular mental health check-ins and access to counseling services are also important components of a comprehensive approach to supporting the psychological well-being of astronauts. By addressing these challenges, we can help ensure that space travelers remain mentally healthy and resilient. Lastly, there's the need for self-sufficiency. Colonies will need to produce their own food, water, and air to survive. This requires the development of closed-loop life support systems that can recycle waste and generate essential resources. Hydroponic and aeroponic systems are being explored for growing food in space, using minimal water and soil. Water recycling systems, which can purify and reuse wastewater, are also critical for maintaining a sustainable supply of clean water. Additionally, technologies for generating oxygen from carbon dioxide, such as the use of electrolysis, are essential for ensuring a continuous supply of breathable air. Achieving self-sufficiency is a key challenge for space colonization. Colonies will need to produce their own food, water, and air to survive. This requires the development of closed-loop life support systems that can recycle waste and generate essential resources. Hydroponic and aeroponic systems are being explored for growing food in space using minimal water and soil. Water recycling systems, which can purify and reuse wastewater, are also critical for maintaining a sustainable supply of clean water. Additionally, technologies for generating oxygen from carbon dioxide, such as the use of electrolysis, are essential for ensuring a continuous supply of breathable air. Achieving self-sufficiency is a key challenge for space colonization. Overcoming these challenges is crucial for the success of space colonization. Each obstacle presents an opportunity for innovation and advancement, pushing the boundaries of what is possible. As we develop new technologies and strategies to address these challenges, we not only pave the way for future space missions, but also gain valuable insights that can benefit life on Earth. The journey to space colonization is a testament to human ingenuity and determination, and with continued effort and collaboration, we can turn the dream of living among the stars into a reality. So, how will we actually build these space colonies? The idea of living on another planet has fascinated humanity for generations. From the pages of science fiction novels to the silver screen, we've imagined countless ways to make otherworldly environments our new homes. But turning these dreams into reality requires overcoming significant challenges. We need to develop new technologies, adapt existing ones, and think creatively about how to sustain human life in the harsh conditions of space. Let's explore some of the most promising approaches that scientists and engineers are working on today. One promising technology is 3D printing. This revolutionary method allows us to create complex structures layer by layer, using materials that are readily available. On Earth, 3D printing has already transformed industries from manufacturing to medicine. In space, it could be even more transformative. Imagine landing on Mars and setting up a 3D printer that uses the planet's own soil, known as regolith, to build habitats. This would eliminate the need to transport heavy construction materials from Earth, drastically reducing costs and logistical challenges. Imagine printing entire habitats layer by layer using materials found on Mars or the Moon. These habitats could be designed to withstand the extreme temperatures, radiation, and other environmental factors that make space so inhospitable. The flexibility of 3D printing also means that we can create customized living spaces tailored to the needs of the inhabitants. From sleeping quarters to laboratories, everything can be printed on site, making the process highly efficient and adaptable. Artificial intelligence will also play a key role. Managing a space colony is a complex task that requires constant monitoring and decision-making. AI systems can help by automating many of these processes, ensuring that everything runs smoothly. For example, AI can monitor the health of the habitat structure, detect any potential issues, and make real-time adjustments to maintain optimal living conditions. This level of automation is crucial for the safety and well-being of the colony's inhabitants. AI can help manage complex systems and make real-time decisions that are crucial for survival. In addition to maintaining the habitat, AI can also assist with scientific research, resource management, and even daily tasks like food preparation. By taking on these responsibilities, AI allows human colonists to focus on exploration, innovation, and other activities that require a human touch. The integration of AI into space colonies will be a game changer, making life in space more sustainable and efficient. Space elevators might sound like science fiction, but they could become a reality. These structures would extend from the surface of the Earth to a point in space, allowing materials and people to travel back and forth with ease. The concept involves a tether anchored to the ground and extending into space, with an elevator car that moves along the tether. This method of transportation could significantly reduce the cost and complexity of getting to and from space, making it more accessible for everyone. These structures would allow us to transport materials and people from Earth to space more efficiently. Imagine being able to send supplies, equipment, and even entire habitats up to a space station, or directly to a lunar or Martian colony. The space elevator could operate continuously, providing a steady stream of resources to support the growing needs of the colony. This would be a significant advancement over current rocket-based methods, which are expensive and limited in capacity. And let's not forget about nuclear power. Energy is a critical component of any space colony, and nuclear power offers a reliable and potent source. Unlike solar power, which can be intermittent and dependent on the availability of sunlight, nuclear reactors can provide a constant supply of energy. This is especially important in environments like Mars, where dust storms can block sunlight for extended periods. By harnessing nuclear energy, we can ensure that our colonies have the power they need to thrive. It's a reliable and potent energy source that could power our colonies for years to come. Nuclear reactors can be designed to be compact and efficient, making them ideal for use in space. They can provide the energy needed for life support systems, scientific research, and even the production of food and water. By incorporating nuclear power into our space colonies, we can create a stable and sustainable energy infrastructure that supports long-term habitation. Combining these technologies will pave the way for sustainable space colonies. By leveraging 3D printing, artificial intelligence, space elevators, and nuclear power, we can create habitats that are self-sufficient and resilient. These technologies will work together to provide the infrastructure, resources, and support needed for human life to flourish in space. As we continue to innovate and push the boundaries of what's possible, the dream of living on another planet is becoming more achievable. The future of space colonization is bright, and it's only a matter of time before we take our first steps towards making it a reality. Looking further into the future, we dream of becoming a multi-planetary civilization. This vision isn't just a flight of fancy, it's a goal that many scientists, engineers, and visionaries are actively working towards. Imagine a world where humanity is no longer confined to Earth, but has spread its wings to explore and inhabit other planets. This dream is driven by our innate curiosity and the desire to ensure the long-term survival of our species. The idea of becoming a multi-planetary civilization is not just about survival, but also about thriving in new environments, discovering new resources, and pushing the boundaries of what we know. This means expanding beyond our solar system to other star systems. The vastness of space offers endless possibilities for exploration and discovery. Each star system could hold planets with unique characteristics, resources, and potential for life. The journey to these distant star systems will require advancements in technology, such as faster-than-light travel or generation ships that can sustain human life for centuries. These technological leaps will not only make interstellar travel possible, but also open up new frontiers for scientific research and exploration. The Kardashev scale measures a civilization's level of technological advancement, and reaching Type 2 would mean harnessing the energy of an entire star. This concept, proposed by the Russian astrophysicist Nikolai Kardashev, categorizes civilizations based on their energy consumption. A Type 1 civilization uses all the available energy on its home planet, while a Type 2 civilization can harness the energy of its entire star, such as through the construction of a Dyson sphere. This monumental achievement would provide us with nearly limitless energy, enabling us to power advanced technologies, support large populations, and undertake massive space projects. But what does this mean for us? It means new opportunities, new challenges, and a new chapter in the human story. Living in space will require us to adapt to new environments, develop new technologies, and rethink our social structures. Space colonies will need to be self-sustaining, with systems for food production, waste management, and life support. These challenges will drive innovation and collaboration, bringing out the best in humanity as we work together to overcome obstacles and build a new future among the stars. And a new chapter in the human story. Imagine cities floating in the clouds of Venus, mining colonies on the moons of Jupiter, or research stations on the icy plains of Pluto. Each of these environments will present unique challenges and opportunities, pushing us to develop new technologies and ways of living. The experience of adapting to these new worlds will change us as a species, fostering a sense of unity and shared purpose as we work together to explore and settle the cosmos. It means ensuring the survival of our species by not putting all our eggs in one basket. Earth is our home, but it is also vulnerable to natural disasters, climate change, and other existential threats. By establishing colonies on other planets, we create a safety net for humanity, ensuring that our species can survive, even if something catastrophic happens to our home planet. This redundancy is crucial for the long-term survival of humanity, providing us with multiple chances to thrive and continue our journey among the stars. It means exploring the unknown and pushing the boundaries of what we thought was possible. The spirit of exploration is deeply ingrained in human nature, driving us to seek out new horizons and expand our understanding of the universe. Each new planet we explore will offer new mysteries to unravel, new ecosystems to study, and new challenges to overcome. This relentless pursuit of knowledge and discovery will keep us moving forward, constantly striving to learn more and achieve greater things. The journey to becoming a multi-planetary civilization is a monumental one, requiring the combined efforts of scientists, engineers, policymakers, and visionaries from around the world. It will take decades, if not centuries, to achieve this goal, but the rewards will be immense. The technologies developed for space exploration will have countless applications on Earth, improving our quality of life and driving economic growth. The experience of living and working in space will also change us as a species, fostering a sense of unity and shared purpose as we work together to explore and settle the cosmos. But it's a journey worth taking. The dream of becoming a multi-planetary civilization is not just about survival, but about thriving in new environments, discovering new resources, and pushing the boundaries of what we know. It is a testament to the indomitable spirit of humanity, our relentless curiosity, and our desire to explore and understand the universe. As we embark on this journey, we will face many challenges, but we will also discover new opportunities and achieve great things. The future of humanity lies among the stars, and it is up to us to make that future a reality. Space colonization is no longer science fiction. It's a challenge we must embrace if we hope to secure the future of our species. But what do you think? Will we become a multi-planetary civilization in our lifetime? Let us know in the comments. Like, subscribe, and share.